I am Sivakumar, Assistant Professor, Department of Chemistry from Arignar Arts and Science College, Krishnagiri. Today we would like to discuss about physical chemistry, one of the topic, bed multi-layer adsorption theory. This theory used to determining the surface area of adsorbents. So what is bed theory? The first one is fundamental principle. The bed, Brunner, Emmett and Teller adsorption theory is a crucial method used to determine the surface area of a solid material. So applicability of bed theory, it is specifically designed for physical adsorption, also known as physisorption, where gas molecules weakly interact with the solid surface. The main key concept of multi-layer adsorption is, this is for unlike Langmuir theory, which is limited to monolayer formation of bed theory consider only the formation of multiple layer of gas molecule on the adsorbent surface. We would like to discuss about the key about the assumption of bed theory, especially part 1. These sites explain the uniform sites. The solid surface is assumed to possess uniform and localized adsorption sites, implying identical binding energies across the surface, and no inter-site influences. Adsorption at one site does not influence the adsorption characteristics of a neighboring site, simplifying interaction modeling. Then multi-layer formation. Gaseous molecules can form multiple layers on the adsorbent surface, extending from the initial monolayer up to the nth layer, signifying continuous buildup. Key assumption of bed theory part 2, equal surface area per layer. The available surface area for subsequent layer, that means second, third and so on, is assumed to be equal to that of the first layer. This simplifies the geometry of multi-layer formulation. Constant heat of adsorption. Next, the topic is constant heat of adsorption. First layer, the heat of adsorption for the initial layer is considered constant across all sides. Succeeding layer, that is next layer, for layer beyond the first, and the energy of adsorption is assumed to be constant and equal to the energy of liquefaction of the gas. Energy of liquefaction. This is the enthalpy released when 1 mole of gas condensed into a liquid, the specific temperature. It signifies that subsequent layer behave more like bulk liquid than adsorbed molecules. Next, we would like to discuss about the bed adsorption equation. Based on these fundamental assumptions, Brunner, Emmett and Teller successfully derived the bed adsorption equation, which is presented in a straight line form, analogous to linear equation y is equal to mx plus c, making graphical analysis straightforward. P divided by Vt, P0 minus P is equal to 1 by V mono K plus K minus 1 by V mono into P divided by K into P0, where P is the pressure of gas in equilibrium with adsorbent, P0 is the saturated vapor pressure of the adsorbate at the experimental temperature. Vt implies total volume of gas adsorbed at the pressure P. V mono explains the volume of gas required to form a complete unimolecular layer on the adsorbent surface. K indicates a constant related to the heat of adsorption for the first layer E1 and the heat of liquefaction layer of EL. Plotting the bed isotherm. To apply the bed equation effectively and determine the surface area, a linear plot is generated from experimental data. This transformation allows to straightforward and calculation of key parameters. The plot y-axis P divided by P0, P0 minus P, then x-axis P divided by P0. Plotting these transformed variable, experimental data point should fall on a straight line within a specific relative pressure range, typically 0.05 to 0.35 P divided by P0. So determining surface area. Now we discuss about the determining surface area. The primary object of bed analysis is to be quantity of the surface area of a solid adsorbent. Once V mono, the volume of gas adsorbed to form a unimolecular layer, is accurately obtained from the slope and intercept of the linear bed plot. The total surface area of the solid adsorbent can be calculated. Next we goes to explain the calculation steps of bed isotherm. The first one is convert V mono from volume to the number of molecule using Avogadro number and the molar volume of the adsorbate gas at standard conditions. Then multiply the number of molecules by the known cross-sectional area occupied by a single adsorbate molecule like a nitrogen gas at 77 Kelvin as a cross-sectional area of approximately 0.162 nanometer. So this yield the total surface area of the adsorbent in square meter per gram, M2 by G. Next, we discuss about significance of critical applications. The ability to accurately determine material surface area using bed theory is vital scientific and industrial domain. Catalysis, surface area directly impact catalytic activity and efficiency. Crucial for reaction design. Next one is adsorption process. Essential for designing adsorbent for gas separation, purification and energy storage. Example, hydrogen storage. Material science, characterizing powder, nanoparticle and advanced porous material used in the membrane, filter and composting. Pharmaceuticals, surface properties of drug particles influence solubility, dissolution rate and ultimately bioavailability and drug delivery. Thank you.